So we are ready to continue with our next talk about full stack type safety by Stefan. Stefan comes to us, he lives in Estonia, but he comes from Italy, and he really complained about our pizza already. There was some pineapple spotted on one pizza. So, not nice. We'll be choosing new pizza next time. By the way, did you check out our stickers? We have really cool stickers. There's still some left, so you can grab some in the end of the event. But without further ado, Stefan, take it away about full stack type safety and how to break less things.
Hi all. I wanted to bring in this topic because the space has changed a lot with TypeScript, and there are newer things coming up, and it keeps changing. And I wanted just to give an overview that kind of simplifies what are the pieces that are nowadays in this space, and kind of give an overview so that it could make it more accessible for everyone to start coding in a full stack type-safe framework. So a little bit about me. I come from Italy. I studied in Politecnico di Milano. I did my bachelor's there in software engineering. Then around 2 years ago, I started working as a software engineer at Quora. And more recently, 8 months ago, I started at Sift, which we have heard a little bit about it. I will also mention some other stuff at the end. But it's been already 2 years since I came to Estonia. And coming from Italy, there are some things that are so much nicer here, because the migration was so easy. Everything is so clear on what I have to do, and the data, I can see it. And similarly, it's a bit like TypeScript and JavaScript, and even the blue color of TypeScript is also in the flag. We like that, where things are easier to migrate in the space of TypeScript. Things can be clearer, although sometimes not as clear, but the data, it's the part that is fundamental, where it's clear what the data is in your application. And why is TypeScript better than JavaScript is not the topic of today. It can take hours and hours, infinite debates. Today I just wanted to bring up one selling point for TypeScript, which is full stack type-safe frameworks. And let's talk more broadly about the problems. My backend and frontend don't share their types. You have this situation where the server is sending some data to your frontend, and you as a coder have to console log the data to understand what's in there. If only I knew the format. And nowadays, one library that appeared is TRPC, that allows making APIs on your backend super easy, and on your frontend you will be able to consume them and see the type right away. Let's explore. This is a whole API endpoint in TRPC, where we have a definition of the route and the main API endpoint. And if you see here, I'm doing so it's the query, and I'm returning hello, which is of a string format. And on my front end, if you have used the React query, you might recognize the use query. You simply call the API dot the route dot the API endpoint dot use query. That's how you call the API. And on your React component, you can simply consume it like this. So now they share their types. I know my frontend that the API endpoint returns a string. The problem number 2 is TypeScript doesn't validate at runtime. So you have the situation where the frontend sends some data to the server, and it was some input from a user. It was not validated. Everything starts exploding. Nowadays, there is this library called Zod, which works super well with TypeScript, where you write a schema, and you're able to extract the type out of it. So let's see. You import z from Zod, and if you do z.string, you get this string schema. And then you can use the schema.parse. If you pass a string, you're getting back your string. If you pass some value that doesn't match the schema, you're getting an error. A bit more complicated, maybe it's you have an object with a username and a string, and if you pass, for example, username.ludwig, it's going to return a value. So my user here is of type string. For example, if there is some data that you're fetching from some random API of which you don't know the type, but you want a specific schema, that's how you can get both the TypeScript validation, and the TypeScript output from it. And tRPC and Zod work super well, where let's say that from your front end you want to send some data to your backend and you want to validate that it's correct. I simply do .input, z.string, so I'm passing here the Zod schema. And on my front end right away I will see that I expected 1 or 2 arguments but got 0. So I'm getting an error on my ID right away. So I can just change it like this, and no errors are on my ID. And for example, if I want to consume it, the query has the input field, and I can just pass it like this. So now they communicate, the server can send error on the front end, and everyone is happy. The database typing, that's also another issue, especially with NoSQL and other parts where, or for example, like you're trying to understand what to get from your database. Extremely complicated, extremely frustrating. You have to extract and make your own types. One library that has come is Prisma, for example, which again works super well with TypeScript, where this is the model definition, so a schema, ID, string, and other parts of it. I can also pass some other parameters to make it easier to use. And then I simply can do Prisma dot name of the schema, and I'm getting all of my methods right away. I don't need to write SQL anymore. And here you can see I used find_many, which gets all the data from it. And then out of here I have this example type, the array. So this is perfectly typed where I will have access to ID, created that, updated that. So now my server will send simply a prisma.example.find_many, and that's it. So my first experience when I tried to put them together was more like this, where you try to piece all of them together and it just doesn't work, things break. It's not something that you do in 10 minutes. However, I want to show you it's doable. It takes just more time. And I wanted to show you like how you can try to use it to fully understand the power of these ideas that come together. One of the examples is with the T3 stack, which is a project where they use you use tRPC, they use Prisma. With tRPC, they also use Zod. And simply, it's a Next.js application with these technologies combined together to make web development a lot easier. So you simply just run npm create t3 app, and you're going to get an app ready to use. So just like rewinding from here, I have the client, the server, the database. And when I put these pieces together, the Prisma is the part with the database. Then I have tRPC and Zod between the two, between my client and server. And without further ado, I wanted to show a demo to actually see how everything works. So this is the folder structure. I have my Prisma with schemas. So this is, for example, here I only have the example schema. We have the source with the front-end code with pages. So this is my front-end component. And here I have in server.api routes the example. This is an example route that I have with the hello API endpoint. So to start my application, I can simply run npm run dev. And on my front end, I see, as soon as it loads, hello world. So let's say that now I really don't want to show world. I want to show, for example, the name of the place that I'm at. And this is sent by the front end. So this is the file that I have this, where I'm calling this API endpoint. If you see, it's API example hello use query. If I want to go back to my API endpoint, I can simply go to definition. And if you see, right away I can go from my front end to my API endpoint in a click. So I want my API endpoint to get an input, and this input should be a string. And if you see here, it's already red. I didn't even save the file. I'm getting already an error here that says that I'm missing expected 1, 2 arguments got 0. So I can super easily say TallinnJS, for example. And another thing, like, if you see here also profile is red. Why is it red? Oh, well, I'm using also my API endpoint here, and maybe I deployed it yesterday and I completely forgot. I can also here say TallinnJS in this other page. So now, if I go here, I see still hello world. I want to use this input. So here, I'm getting my input, and I'm passing it here. Input. And hello, TallinnJS. So the other thing to talk about is how this all works. So if you use React Query, you're familiar, but at the beginning, I'm getting this, when I use query, I'm getting this object that has some properties. There is the isLoading one, isError, and then I have the data. So what happens is that if I access the data here, you can see here that the data is string or undefined. This is because the React, you want to render the whole component first. You don't want a query to be blocking in the rendering. So what we do is we check that it's loading. We check that there is an error. And if there isn't, you can see here that the data now is a string. I have from type safety, I have like React Query imposes me to check that something is loading, something is errored, and then I can show the data. So I don't have like random errors appearing all over the application. So now let's play with databases. Let's create a new schema where I'm using, again, this as an example, but let's call it event. I want to have a list of all the events happening in my area. So let's just add name string. So how do I add now? So with Prisma, it's simply an npx prisma db push. And if everything works correctly, it's done. I've created a new schema. Then I will restart my dev server, just that all the types are picked up. And that's all. One cool thing about Prisma is that I have also like some dev tools that allow me to explore what's inside of it. So I have this thing called Studio, Prisma Studio. And here I can see all the old models, event, an example. And you see here, it's already like I have the model example. I can play even with this. I can add a new record. Well, again, I can say TallinnJS. And then I can save it, and I've added this to my database. What I'm going to do now is I want to get this data, right? I have like my database, and I want to get all of the list of events. So I create a new route, new API endpoint called get events. I have to call, there is public procedure and private. Simply public is not authenticated. And if you see here, when I press dot, I'm getting right away suggestions. In this case, I just want to query. I want to get data from Prisma. So here I took the input. Another thing that I'm getting here is the context. So simply context will have the Prisma context. And then I press dot. And I see here my models, event, and example. And then I press dot, and I'm getting find many. So, and from here I can just return, await this, and I forgot here to make it asynchronous. And why is it not working? Let me just, the other thing that sometimes happens, which hasn't happened when I demoed it, live demos. Okay, so sometimes you have to restart the TS server, it doesn't work. So you restart it, and now finally the error goes away. So if you see here, the return type of the events is a list of events. If, for example, I forget to return this, the return type is void. So I'm also getting like these insurances from TypeScript that I remember to do everything correctly. So to call it, I simply do api.example.getEvents.useQuery. GitHub Copilot is not needed. So here now I have my events API. And what I can do is just check that everything is loaded. So if is loading, I will show an is loading state. If it's error, I can also throw here the error and error. And now I can access my events through the data. I've created a handy component called list events where I can pass events. And then I can pass my events API.data. And here I'm getting an error. Well, what's wrong here? So type event is not assignable type string. Yeah. So events accept strings. This is still the event object. So what I can say is just map over the events and just get the name. As you can see, this was in the database. I'm getting on my front end full type safety. I know that this name, that event has a name and it's a string. And now, if I go to my application, oh, TallinnJS, no errors, nice. The other thing that maybe you want to do is add events. Like, I don't want to manually do stuff on the database. Let's go again in the example, add event. So public procedure dot, in this case, I want an input. Let's just say it's going to be a string. And then this is a mutation. I want this to change some data. And what I want from here is the context, because I want to interact with Prisma, and I want the input. So let's see. Context.prisma. I have access to my Prisma. Event.create. So let's see. I want to create. Oh, look at the handy comment. So I need to pass an object with data property. And then from here, I can just see I need name, and all the others are automatically generated by Prisma. They're not required. So here, I pass the input, and then here I can await it. And when I await, I need to make this asynchronous. And now I have an API input that adds data to my database, and it's type safe. If here I'm passing a 3, I'm getting an error. So if the input is something different, something that is not expected, I will get an error from my ID. And on the front end, again, I can simply, so I will create a mutation, dot example, dot, I want the add events, dot use mutation. And the mutation object has a mutation function, mutate function that will, simply you have to call the function with the data that you want to send to the backend. So here I can have I have an input component that accepts a mutate function. So if I do mutation.mutate and I save, I can see here a nice form. So if I pass, for example, Rome.js and I refresh the page, Rome.js. If I pass anything, I will get anything. That's how easy and reliable it is to make these changes, where right away I didn't have any errors, not because I ran this demo multiple times, but because it's safe from the TypeScript level. And so let's just rewind what we did. We changed an API endpoint based on some inputs, created a new schema, added an endpoint to add data to a schema, and also added an endpoint to fetch data from that database. And everything took around 10 minutes and no errors on the front end. Thank you. That's my talk. And if you want, me and Randall work at Sift. It's a we make products for cybersecurity, and we have multiple locations, London, Barcelona, and we are fully remote in Europe. It's super nice. And if you want to visit the website or try the products or just talk with us, feel free to do so. Thank you.
Thank you, Stefan. So guys, do you have any questions? Oh. Oh. Excuse me, this is like authority figure.
No, I just wanted to ask whether you use T3 in Redshift.
We don't, but at some point, we are kind of like, there are some projects to build TRPC-like experiences in our products. So we have like 3 main products, and me and another person are working on building things that look similar to TRPC to bring these type reliability and advantages.
Similar to TRPC, but based on what?
Based just on TypeScript and our code.
Oh, okay. Okay, something custom.
Yeah,
Like,
yeah, exactly.
Okay, okay, cool.
Thank you.
Hello, I have a question. How will it work if you decide to use infer keyword?
Sorry?
If you decide to use infer keyword, which Ilya mentioned before.
Yeah, so I think the cool thing about TypeScript is that what he showed is like how to leverage all this power. Me as an end user, I don't even need to use the infer keyword in this case, because everything, like his work that he's doing on the library to make TypeScript work super well, me as an end user of the library don't need to use like very complicated TypeScript. I can be on a very surface level that. But if you want to use, this is like TypeScript files. So you can use infer, you can use pretty much anything you want.
But I mean, if I decide to, let's say, include more complex TypeScript inside my, let's say, database, or probably I have an object which uses more, let's say, still like key in some other complex type, and it might fail probably, or probably if you decide to use some generic inside generic and also loop it otherwise. Will it fail somehow, or will it produce the more strict API?
I'm not sure, depends on the use cases, but in the case where I'm working, for example, with objects, I would use Zod and create like these schemas with Zod and then infer the type out of it. When you want, for example, to have these functions, like usually they are only on the server or only on the front end, right? So what you can do is simply, if it's just the API endpoint, it will work perfectly. Like if I use infer, for example, in the API here and have a super complex function, if the output is, for example, this number, it will know that. So if in this function you're creating a function that has like very complicated TypeScript stuff, if the return type is standard, it will propagate to the front end. So, not sure if I answered the question.
Yeah, but usually in the production code it goes with more generic stuff. I mean, it's not always number or string. That's what I'm trying to ask.
Yeah, in the case, for example, the input has like, can be some specific objects. You can then like have the function here understand with the generics how to like generate a new method.
So it will not fail.
It will not fail.
Okay.
We can try if you want. Like if you had example, it would be interesting to see. And I mean, the whole thing is also like the world is evolving very fast around these things, where you can see like changes happening in the space super quick, and if it's not working today, it might work tomorrow, you know, like everything is open source. So
I don't know anything about TypeScript, but isn't there a return type hinting you can use? Like in your example? I don't know. So anyway, my question is, how do you sync the schema between the backend and the front end if you don't have it on the same monorepo?
Yeah, in this case, like it works really well because of the monorepo. If you want to go and have like something different where you have like the schema file in other projects and things, it will not work. So you need to like do things differently where you just have to like rely then on GraphQL or other things to build similar experience, but they're gonna be similar. Where you have to generate the types, you have to do all these kind of things that are making it.
I mean, like a deploy hook that syncs it to the other repo.
Yeah,
Something
potentially, yeah.
pornographic like that.
This is like the power of the monorepo where everything is there and everything is shared.
So basically, go monorepo.
Yes.
Okay.
Exactly.
Cool.
Yeah.
Thank you, guys. Any more questions?
What TRPC uses Underhood and like Ajax or whatever, JSON, and like does it on the client side get all these types and packages from some generated TypeScript code or from some schema response from the server?
So
yeah, that's it.
you can use whatever you want in terms of the, for example, Axios and things like that. You can choose your own, like it's quite flexible. This is like a project and it's created quite standard. The main libraries that you're kind of forced to use, I guess, is React Query in the case of a React application, because it just provides a lot of these features that make things easier. And in terms of other libraries that you use, I'm not 100% sure. But it's an open source project, so you can check yourself and see. But it's more of a building structure where you can add your own building blocks and extend it as you wish. And the other question was around how it infers the types.
Using some generated TypeScript types, or
It doesn't generate anything. Yeah, there is no like script running to generate the types. It's all like inference. So when you call a function, it just infers the value. So, for example, in the GraphQL world, you have to generate the types with some scripts. Here, it's just TypeScript. It's like your normal TypeScript world, but
so it uses TypeScript.
yeah.
Thank you. Thank you very much. So please, a round of applause for Stefan.
Thank you.
And an awesome yellow t-shirt. Ta-ra-ta-ta-ram. There it is. Oh, sorry, CSS. Yeah. Thank you.